Here we're asked to determine whether the function is one-to-one, and if so, on part A, write an equation for the inverse function in the form of y equal f inverse of x, and on part B, graph f and f inverse on the same axes. And so we're given the function f of x is equal to the cube root of x plus 5. And we first need to determine whether this function is one-to-one. Well, the easiest way to determine if a function is one-to-one is to graph it and see if it passes the horizontal line test. Now, remember, if it passes the vertical line test, that indicates it is a function. And if it passes the horizontal line test, that indicates that the function is one-to-one. We know it's already a function. It tells us so in the problem. So we can graph it and we can just see if it passes the horizontal line test, and that'll tell us whether it's one-to-one. Well, we know how to graph this one. We know it's a cube root of x as our parent function. And so the cube root of x, we know looks like the x cubed graph laid over on its side. So something like this. And then we have shifted that graph. The plus 5 on the inside tells us we've shifted that graph 5 units to the left. And so the graph of x cubed plus 5 would look something like this. And so again, we know it passes the vertical line test. We know it's a function. We're trying to determine if it's one-to-one, which means we need to perform the horizontal line test on it. So we draw horizontal lines everywhere on this graph. And as long as it only touches the graph once, then it does pass the horizontal line test and it is one-to-one. And so this one does pass the horizontal line test because all of those horizontal lines only touch the graph in one spot. And so we can proceed with the problem because it is one-to-one. So part A asks us to determine the inverse function. Well, the main idea with inverse functions is that we're switching the input and the output. We're switching the x and the y. And so that helps us determine our input functions, our inverse functions. So first off, just rewriting that as y instead of f of x. Y is equal to the cube root of x plus 5. And then we can find our inverse function by switching our x and our y. So where there's a y, we replace it with x. Where there's an x, we replace it with y. And now we want to solve for y. We want to isolate the y. We want to put it in y equal something form so that we will have a function. So to get the y by itself, the first thing we have to do is get rid of the cube root. Well, we undo a cube root by cubing it. So we're going to raise both sides to the power of 3. Again, we have to do it on both sides. So we get x cubed on the left, and on the right, the cube root and the cube power cancel each other out. We get just y plus 5. Remember, we're still trying to get y by itself, so we can move the 5 over. We can subtract 5 from both sides to get x cubed minus 5 is equal to y. Now that we've got the y by itself, and we know it is a function because that's what it means for the graph to be one-to-one, it means that its inverse is a function also, then we can use the inverse function notation, and we can rewrite that as f inverse of x instead of y. So f inverse of x is equal to x cubed minus 5. So there's the equation for the inverse function. That should answer part A. And then on part B, it asks us to choose the correct graphs of f and f inverse. It tells us that the graph of f is a red dotted curve and the graph of f inverse is the blue solid curve. So looking at our answer choices, we know we can already rule out answer choice D because that says the function is not one-to-one, and we've already seen from graphing the original function that it is one-to-one. So it's not answer choice D. So on A, B, and C, they've got the original graph F graphed as a red dotted line. And so we can see the one that matches what we have graphed for our original function up here. It looks like the x cubed graph shifted 5 units to the left, which means it's either going to be option A or option B. Notice it's not answer choice C because answer choice C has that graph shifted up when our original graph is shifted to the left. So it's either going to be answer choice A or answer choice B. Both of those have the original graph graphed correctly. We just need to see which one has the inverse graph graphed correctly. And so the inverse function is x cubed minus 5. Again, that's one of our parent functions that's been shifted, so we know how to graph it. We know that the x cubed is our parent function. We know the x cubed graph looks something like this. And then the minus 5 on the end of it is going to shift that graph down 5. And so we get our x cubed graph shifted down 5, should look like that. So when we go back and we look at option A and B, so answer part B of the problem, answer choice A and answer choice B. Well, of those, answer choice A looks like it's got the cube graph shifted to the right, which is not correct. We shifted our graph down because of the minus 5 on the end. So answer choice B is going to be our correct answer because it has the blue graph, the x cubed graph, shifted down 5 units. So it's got our original graph, the F graph, shifted to the right 5 units, the x cubed graph. The cube root of x graph shifted to the left 5 units. And then it's got the inverse graph, x cubed, shifted down 5. So that's answer choice B. Now back up on part A, we found our inverse function here. We just need to enter that into our answer choice. Obviously, again, not answer choice B because it says the function is not one-to-one. We know it is one-to-one. So we select answer choice A, and then we plug in the x cubed. And so again, you can either use the caret key or you can use the power key, the power in the toolbox. And so we have x cubed, and then we're going to arrow over and put in our minus 5. And so now we've got part A answered with our inverse function, x cubed minus 5. And we've got part B answered with option B, which was the correct graph of f and f inverse.